Hello YouTube! Welcome to the second part of this tutorial series where we add a body and a facial animations for metahumans. If you haven't watched it yet, then please do watch the first part to know what we are doing. Okay, before we go any further in the second part, let's activate some plugins and download some files. The plugins I will activate are the Logic, IClone Livelink, and a Livelink. If you want to follow what I am doing step by step, then you can download the Reolution Launcher and get the 30-day free trial of IClone 8. Okay, anyway, the Logic is an engine built-in plugin which helps move bone data between two different skeletons. We don't use this plugin personally, but the files we download later on will take advantage of this plugin, and that's why it is required. We get an error message if we don't have this plugin enabled. The iClone Livelink plugin is a third-party plugin to connect the iClone 8 to Unreal Engine. If this plugin is not showing up, it must be downloaded from the Epic Games Launcher. iClone Unreal Livelink is an engine plugin and can be activated in every project after it is installed. The third and final plugin is a Livelink plugin, which is a common plugin to connect other softwares to communicate with Unreal Engine. In this example, it's the iClone that will communicate with our project here. Now that the plugins are activated, let's download some files. The dummy characters can be downloaded without needing to log in. If you want to connect the iClone to Unreal Engine, then you will need the Unreal Livelink as well. We don't cover how to install the Unreal Livelink plugin as it is a subject of a different tutorial. Let me know if you want to see a tutorial about that. Okay, so this metahuman livelink kit. You get this zip file when clicking this download button. And this zip file includes metahuman dummies, which shares the same skeletal structure as the metahumans do. We have a short, medium, and a tall versions of the characters, and we can choose if they are thin, normal, or overweight. Having all these archetypes at our disposal significantly reduces bone deforming, as no stretching is required in any direction when playing the animation. This zip file also includes the content folder. This content folder includes pre-made blueprints to control the character bones and morph targets. That logic is required when using a livelink to transfer the bone data. The metahuman character and iClone characters are built differently, with having different kinds of morph targets, so it is necessary to adjust them to work with together. Fortunately, all the fine-tuned data is included in the blueprints that come with this content folder. So all we need to do is to copy this content folder over our project content folder. So I just drag it here and replace everything, and we are good to go with creating animations. Okay, so the first thing to do is to see what kind of body the metahuman character has. So after you have brought your metahuman to Unreal Engine, click it and go to body. Here we see the skeletal mesh, and in this case it's male, short, normal weight body. So here are the dummies that was in the zip file. I extracted them in a folder. Here we see the male, short, normal weight body. So this character matches this character. So we use this one. So here is my IClone open, and I bring the male short normal weight here, like this. And now I'm gonna zero out the X, zero out the Y, and we can apply any animation to this character. But let's not make this too easy, because while we are here in the iClone, I will show you a brief example of why I love to use this software. In my opinion, the most powerful thing in iClone is that every skeleton that is brought into iClone works together. Every facial animation, every pose, and every animation are 100% compatible with each other. To illustrate that, I will add one animation from within iClone to this character, and then I will add another animation from Mixamo, and let's see how they work together. So I'm just gonna create a room here, so this is easier to see what's happening. Let's go to animations. Let's go to motion, and let's put a walk relaxed loop for this guy, like this. So here is our loop. I'm gonna zoom out a little bit. Okay, and let's put this in 30 fps so there aren't so many frames in this animation. Okay, so now we have our loop. When we press play, this guy is walking here. Okay, now let's combine another animation to this. I opened the Mixamo, and I found this praying. So let's do the thing that this guy walks here and then kneels to pray, and let's see how we can combine these. So I'm gonna download this 30 frames per second. Let's do only the animation, so without skin, and download. Okay, now here we have our animation, and I'm just gonna drag and drop it to our iClone guy here. But let's first go somewhere here that we aren't overwriting the previous animation. Now let's take praying, add it to this guy. This automatically notice that this is the Mixamo character. We don't need to perform list, and 30 frames per second is okay, and I can just convert. And just like that, we have the Mixamo animation here. So when we play this, this is the guy is kneeling and then he is getting up. Okay. Now, if we want to basically blend these, I can drag this spraying animation over the walking animation, and now this guy is walking and he is starting to kneel. To make sure that nothing clips through the floor, I can check the foot contact and hand contact. So now even if the animation tries to go below this floor level, it will collide to this surface. Okay, so let's fine tune this animation a little bit. Uh, right here, when he has kneeled, let's fine tune the hands. So let's click the character, go to motion, and let's edit the motion layer. This edits the layer. This adds a new motion on top of the original motion. So we can just start fine-tuning this original motion as we see fit. Let's put these hands closer together, maybe rotate a little bit like this. Put it here, and I think this is looking good. So now when we play, as he kneels, he puts his hands together. And maybe he bows his head, so in around in this time, let's go back to motion layer, let's click the head, uh, let's add original key to here, and maybe around in this, we gonna kneel the head like this. So now when he kneels, yeah, I think this is looking good. The head movement may be too much. So motion layer head is here. Maybe like this. Yeah, this looks better. Okay. Now when he stops praying, we gonna release our custom motion layers. And I think the easiest way is just to fine tune the weight. So here he stops it. So let's start. Let's open animation layer so we can see all our layers. Let's add a weight key here, and maybe around in this part we're gonna set the weight down to 0 and it's keyed here. So now our motion layer isn't doing any weight, and this guy can stand up like this. And there we have our ready animation. The shoulders are looking kind of funny, so let's do a little adjustment to those also. Okay, so what we can do to fix this stiff shoulder? We can go and try to go to motion modifier. This has all kind of cool settings, and we can preview them. So we can, for example, change the lean method. We can lean back, we can lean forward, we can put our neck back and forth, we can put our head back and forth, and so on. But what we need is elbows, shoulders. So let's just put shoulders down and click OK. This should adjust the shoulders. Yeah, they are not stiffing out anymore. This looks much better. So now we can watch the whole animation. We walk here, kneel to pray, bow the head, praying is done, and we can stand up. Okay, so that was a brief example of why I like to use the IClone. But let's create the animations for our metahuman character. Let's create a walking animation and an idle animation. Okay, so let's start with the walking animation. And let's do this in a traditional way. So let's add animation here, then export it, and then import it to Unreal Engine. Okay, so let's go to frame 0, choose the character, and or just drag and drop this animation to character like this. Then let's make sure that we are in 30 FPS. So I open the settings. FPS is 30, so good. Then we're gonna find the end frame here and click the set end frame. Now, if we want to preview this animation, we're gonna set the looping on here, looping. Go to frame 0, press play, and here is the animation. It's seamless walking animation. And this fits for the character quite good. Okay, so let's use this one. To import, we go to File, to export, we go to File, Export, FBX. Target is Unreal, 30 FPS. Let's set the range just to be sure, 0 to 145. We don't care about the texture size because we only import the animation. So it doesn't matter what these settings are. To export, we just press export. I have some testing here, so I just remove everything, just like this, and name this metahuman walking. Okay, metahuman walking. Save this, and that's it. Now, in Unreal Engine, we're going to import this animation. Okay, before we are doing the import process, we need to adjust the metahuman skeleton because the skeleton's retargeting or import settings are not as good as they can be. Basically, if we open the original UE4 mannequin, go to the skeleton setting, and then open the retargeting settings. Here, these are the settings. Basically, root is set to animation, pelvis is set to animation, and everything else is set to skeleton. If we look at the metahuman, go to skeleton, go to retargeting, we see that these are animation, then there is the animation relative, and yeah, they are animation relative, not the skeleton. How we change them to skeleton? So root was the animation, pelvis was the animation, so we change pelvis to animation. Everything under pelvis was skeleton. We can right click and say recursively set translation to skeleton. And we can do that to every child here. And now all these are skeleton and we are good to go with importing process. Okay, so let's go to some folder where we like to import. I created anims and metahumans folder here. I go to import and there are some some testing stuff I did earlier, but metahuman walking was the walking animation. So let's import that. Mm, this menu here came with the Reallusion Auto Setup plugin, but in this case we aren't importing any characters or anything, so I just leave this disabled. So we disable this whole process of importing character creator characters. This is the traditional menu, and here we do a few adjustments. First of all, we don't import mesh, we just want the animation. For skeleton, we choose the metahuman base skeleton. This skeleton is the skeleton that all metahumans uses. We want to set use default sample rate to enabled. This forces the animation to 30 FPS. It's important to check this. Animation length can be animated time. We manually adjusted the time when we exporting. It should be okay. Yeah, and I think that's it. So let's start importing process by pressing import. So our animation is here, metahuman walking, and we can test it out. Let's create a copy of our metahuman character. And in this copy, let's go to body, set animation mode to animation asset, and drag these pants or this animation to this anim to play, like this. And here is the animation play. Yeah, and I think it looks quite good. Mm, Even though this looks quite good, let's do a little bit of adjustments for this character. Um, I think the hand movements of this character could be a little better. They seem to go too far apart from the body, so let's fix that in IClone. To make our life simpler while doing the fix, let's do it by using the Livelink. Livelink allows streaming data from iClone into Unreal Engine in real time, which means we can adjust the animation and see the final results here. This removes the trial and error when we try to fit the animation to suit the actual metahuman. Okay, so before we can start the streaming process, we need to do some adjustments for a couple of blueprints. Let's click our metahuman character and go to blueprint. And here we need to activate the live link. Or we need to activate the live link listener. So whenever we get the data through the live link, we can adjust the animations. So let's add a new component, which is like live link skeletal animation. Okay, let's click it. We can see all the available functions here, and what we want is on live link updated, like this. Now let's go to body, and I tested it previously. This is none to begin with. So basically we need to set animation mode to animation blueprint, and for blueprint we're gonna use the same blueprint as our skeleton name is. All these blueprints comes with the metahumans, so we just need to find the same name, blueprint with the same name, m underscore srt, m underscore srt, normal weight, and that's it. That's our blueprint for this character. So all the metahumans that are sort and normal weight shares the same blueprint. This is basically metahumans commons male normal weight body. So all the metahumans share the same blueprint. So let's open it. And in here, what we need to do is go to animgraph and add one node before all these post nodes. We add the livelink node to here. So let's type the livelink and find the livelink pose. So whenever we get the livelink data, we do that and then we do some other stuff. Okay, so when the livelink sends data, it will send a subject name to which defines who is receiving the data. So when the subject names are same, the data is sent to that particular character. So let's create a variable out of this subject name, because there can be different named subjects. Okay, so like this. The default name is okay. Let's compile. And this animation blueprint is ready. Now, back to the character blueprint. We're gonna take the body. We're gonna take its animation class. I think anim instance. Then we're gonna cast. So cast to the animation instance that this character is uses. So this same animation blueprint we just edited. So cast m underscore sort normal weight anim pp. Okay. Then we want to set the variable we created in there. Oh, there is some my testing. I removed them. Okay, so I'm gonna open the blueprint to show what is happening. So we created a variable called livelink subject name that passes the livelink data here. And here in character blueprint, we pass some data to here. So we go from this character to our animation blueprint. So let's create another variable about of this. So let's just duplicate the original. This livelink face comes with metahumans, but now we're gonna duplicate it and name it body. And pass that to here. One last thing to do in this blueprint is take the body and say livelink setup. This function came with the zip file we extracted here. So there are some data to adjust the body and facial animations when we do the facial stuff. So this is required. The target is Reallusion function library. We don't need to know what this does. We just need to use it. Okay, so the subject is this livelink subject. And now the system is ready. Okay, let's close the blueprint. Close the anim blueprint and go here. Let's delete this other guy and duplicate this again. Okay, now when we click the character and go to the root component, we see all the variables, and here we see the livelink body we just created. So here. If we click face or body, these are empty. Whenever there is data coming to Unreal Engine, there is something here. So no data is coming through. As we see, this is empty. To allow the data coming through, we need to activate the livelink. To activate it, we go to Window, Virtual Production, and Livelink. Without activating the livelink plugin, this menu isn't here. So we need to activate it. Okay, and now when we activated the IClone livelink plugin, there is shows a IClone livelink. And the IClone listens to this port. We don't change this. Let's just click OK. Okay, and now everything is ready. Status is receiving, so Unreal Engine is constantly sniffing out if there is some data coming through the IClone. Now, when we go to IClone, and here we go to Plugins and Unreal Livelink. This menu here comes after installing the Unreal Livelink, which we saw earlier in this video. So we open that, go to Link, and here are all the actors that are in our scene. Well, whichever is highlighted here, its data will be sent to Unreal Engine. So let's disable everything else but our character. Okay, this character has a name called M_T normal body. That is important. Let's click the link activated, go to Unreal Engine, and now when we click the character and click the body, we see there is something. There is M short normal weight body. So Unreal Engine received the data which came here. It received it by the same name. So we know that this name means this character. Okay, and whenever we put set this as our variable. Okay, I think I know what the problem is. We manually changed the body here and set it to none. So let's just put animation mode to animation blueprint, and anim class is this male short normal with anim pp, and now the data is transferring through. Okay, so whatever is playing here is instantly shown here in Unreal Engine. So basically, because I have two screens, I just put this IClone to another screen, hit the play, and we can see what is happening. And now I can adjust the animation in IClone and see the results in here in Unreal Engine. So let's start goofing around. I'm going to copy this metahuman, put it next to this one that plays the animation asset. I'm gonna set livelink body to, oh, I don't have streaming on anymore, so let's see what is the problem. I'm gonna disable everything but our character and then activate the link. And let's see if the link works here. Now the link subject Do we see it? Yes, now the link is working. We can see the broadcasted data here. Let's go to body and change the animation mode to blueprint because there was logic in the blueprint that was receiving the data. Okay, turn on the animation, and here we see our metahumans walking. Another one is walking by using the animation asset, and this other one is walking by receiving the data from IClone. To adjust the hand, I think we can just click the animation, go to motion modifier, and start adjusting these values here. I know that there are settings that affects the hand position, so I think it was the elbow. Yes, we need to adjust the elbow. So let's play this animation and try to adjust these values here. Yep, this is it. So let's just put this a little bit closer to our body, and I think this looks better this way. Now let's see how it looks in Unreal Engine. And yep, uh, it's maybe even too much. Let's just fine tune a little bit. We can go really extremes here. So I think something like this. Just a little bit closer to body. Yeah, I think we go with this. So after we are happy for the adjustment, let's click OK, and this setting is baked into this animation. Now we can export this again and do the import process. So file, export, same settings, metahuman walking, then import to Unreal Engine. And here is our new result. And this is absolutely fantastic. I am extremely happy with the walking animation. Extremely happy. Yeah, so let's do the idle animation next. Okay, so let's go to iClone. Uh, I searched some good idle animation already to save some time, and I think we can go with the idle 01. So let's go to frame 0 at the idle 01, and this is the animation. It's a very long idle animation, about 700 frames, but I think that doesn't matter. So let's go to final frame and then set the end frame here, and let's see how this loops. Yeah, it loops okay. I'm not sure what this transform is. I'm just gonna delete it. But yeah, this animation looks pretty good. So let's go File, Export, same settings, and name this metahuman idling. Now back in Unreal Engine, let's just let's save the previous animation and let's import the idling. Disable this character creator import and import it with traditional method. No mess. Skeleton is metahuman skeleton. We use the sampler rate of 30 FPS, so let's enable this. And then we can. Did we import the correct time here? It's 0 to 748. Yeah, it automatically recognized it, so I think we are okay. So in Unreal Engine, let's import. Okay, now we have the idling, and let's see how it looks in this character. Draw the idling here. Yep, looks extremely good. Okay, let's use these two animations. Uh, let's create a simple blend shape that blends between the idle and walk, so we can walk around as this character. And after that is ready, I think this first part of this tutorial series is completed. So let's create animation blend space 1D using the metahuman blend space idle walk. We do extremely simple movement. Okay, so when the speed is 0, we idle. Is this some kind of new system? Oh, holding the shift, right. And walking while the, let's see, grid divisions is I think 1, so there are only 2 ways. The value is 100, I think that is slow enough. Okay, let's leave this here. Okay, now how we can control the metahuman. I think the easiest way is just to let's duplicate this metahuman and put the uh, suffix ppgi game. Okay, this game character. Let's remove all these lifelink logic, so we don't need to any external data to control this character. So let's just remove all this like this. Now let's open our third-person blueprint and let's just copy all the movement logic here. So copy and let's paste them here in metahuman blueprint. Okay, compile. There are some errors here. Let's see. Metahuman is not the playable character, so let's change the parent class to character like this. Error should go away. Let's create a variables like this. Let's see how our character looks when we are going to viewport. Yeah, I think this character should be somewhere around here. Uh, let's drag the game character. Okay, put it a little bit down. Okay, something like this maybe. Yep, that's good. Uh, character is facing the wrong way, so I think I'm gonna change the root rotation to -90. Yep, compile. Mm, let's use the auto possess. So we auto possess this character. We don't need to change the game mode settings or anything. We just pose it manually here. And let's try to play and see what is happening. There are some errors here. Let's see what errors. Oh, old logic here. Uh, I think this is the wrong. This is my some other testing, so I'm just gonna remove everything. Doesn't matter. It was completely another blueprint, so nothing wrong with this blueprint. Let's play. And what the fuck is that? Jesus. Okay. I'm gonna eat you. Um, yeah, we are missing the camera here, so let's just add same kind of camera than this character has. So camera boom and follow camera that are in capsule component. Okay, like this. Now let's play. And we have a character that we can move. Easy peasy. Lemon squeezy. Okay. Uh, next, let's change the movement speed. So character movement and max walk speed. I think it's the 1 meter per. Was that in second? I hope not. Yeah. Let's see how this fits for the walking animation. Oh, what is this error message? I think, is there any valid check here? Is subject enabled? If there is something, then do this, otherwise don't. Okay, let's see if that fixes the error message. Yep. Okay, to demonstrate that is this speed enough, let's just force the animation. So select the body and select the animation asset and select metahuman walking. Okay, so now when we walk, this is too fast for this animation. Okay, I fine-tuned the walk speed to 50 and I think this is okay. The animation itself is a little bit difficult for this kind of animation because this character holds the foot in the ground for so long. If we want to do this perfectly, we would need to use the root motion movement. But we aren't going to do that in this tutorial. Okay, but let's create a animation blueprint so we can switch between these two modes. So let's go to our animation. Let's create the animation blueprint from our metahuman base skeleton anim.pp simple walk. This is extremely simple animation blueprint. Basically what we are doing, we take the blend space idle walk and pass that as the final output. Create a variable of the speed, name it speed, and then let's just open our third person character and let's copy the animation from there. So let's go to the third person. Let's see what animation this guy is using. Let's open it and copy all this logic here. There is the speed logic here, so we can use that. So copy it and paste it into this metahuman anim blueprint, like this. Compile. Is in air, we don't need that, but let's just create a variable out of this. Okay. And I think we are good to go now. Name is speed. A maximum value is 50, of course, because that was our maximum speed for the character. Okay, now this is working. So we are idling. Then if we starting to move, we are playing the walking animation. When we stop moving, we go back to idling animation. Okay, so basically what I did was I recreated the blend space because there was some problem with it. Most important thing here was to set the maximum value to 50 because our character's maximum value was 50. They need to match so the animation is played at the right speed. The animation blueprint stay at the same. Here. So basically in event grab we get the character speed and that speed controls the blend space. Okay. So what I want to do next is this character to have the same kind of movement logic than the third person character has. So let's just see the settings that the third person character has. First of all, class defaults. It's important that the character is not inheriting the rotation of our controller because otherwise our character always looks the same direction as we are turning the mouse. So let's remove that. I think there are some settings in the camera boom. It inherits everything. So let's check the camera and I think let's test this. Does this work? We have free camera. Okay, only problem is that our character doesn't turn where our camera is pointing. And I think it was in the character movement. It was something like rotate towards, let's see, yeah, orient rotation to movement. Let's check that. And now, yep, absolutely perfect. So now we have a working character and we can see the facial expressions when we turn the mouse. This is important in the next part when we add the facial expressions. The second part is coming to an end, so let's wrap this up. So what we did here in a nutshell. We used IClone 8 to create the animations. We used the dummy characters that share the same bone structure as the metahumans do, and these also shared the same body shapes than the metahumans do. There were multiple different body shapes and we chosen the same type as we had here. Okay. Then we created the animation we wanted and exported it. In Unreal Engine, we made sure that the skeleton had correct settings. So we went to skeleton settings, checked out the retargeting, and then retargeted these in similar way than they are in the Unreal Engine template mannequin. So root and pelvis is animation and everything else is skeleton. After that, it was nothing more than to import the file we exported in iClone. After the file was imported, it was safe to put into any metahuman character. All the other stuff we did here in the iClone was just to demonstrate the capabilities of the iClone. We barely scratched the surface and was able to put together quite nice animations, and we were able to fine-tune the already made animations. In the next part, we will focus on facial animations. Mm, the hardest part in facial animations is that how we can create a system where we can play the facial animations at will in mid-game. For example, if there was something hurting our character, how we can express the agony in this character's face while keeping all the other animations playing. So that is the thing we are focusing in the next part. But this body animation part is over. I really hope you learned something new. If you liked the video or learned something, please like the video and subscribe the channel. There are many more videos about animations coming, so I cannot wait to show you what we are up to in the future. Thank you.